let's differentiate this function. Now this is implicit, right? Because we have x's and y's on both sides, and we don't have explicitly y equals something, right? We don't have y equals something here. We don't have that. So this is an implicit function, and we will use implicit differentiation. So let's start here. We can see this first term here. This is a power, right? I got something to the fourth power. So general power rule, derivative of the outside, 4, 2y squared minus 5 decreased by 1, times the derivative of the inside. Now be careful. Derivative of the inside, this y is an unknown function of x. So when I do this, there's really an f of x here. So this is going to be, bring the 2 down, we'll get 4y, but remember it's y prime. It's the derivative of the outside times the derivative of the inside. Derivative of the outside times the derivative of the inside. And the derivative of the minus 5 is just 0. So here's the derivative of the outside times the derivative of the inside. All right, derivative of the outside is right here times the derivative of the inside. Move on over here. So the derivative here is just going to be minus 10x to the fourth, and then the derivative of the negative 1 is a 0, derivative of 0 is 0. So this is all equal to 0. Now we're trying to solve for y prime. We've got it right here. So let's see what we can do. Let's clean it up a bit. First of all, the 4 times the 4y, I can write that as 16y, and then 2y squared minus 5 all cubed times y prime minus 10x to the fourth equals 0. Now I'm going to add that to both sides, so I'm going to get 16y quantity 2y squared minus 5 cubed times y prime equals 10x to the fourth. Now I can get y prime if I just divide by that, so we'll get y prime is equal to, how about 10x to the fourth over 16y 2y squared minus 5 cubed, and just a little bit of reducing. 2 will divide each of these. How about 5 of those, 8 of those? So I'll write it over here on the right. So we'll get y prime is equal to 5x to the fourth over 8y 2y squared minus 5 cubed. There we go.